In this video, I want to show you guys how to train a Deepseek R1 Llama 8 billion with GRPO. This is another way to train a Deepseek model or LLMs in general that is one step further to fine-tuning. So let's get into it. Let's talk about GRPO. GRPO stands for Group Relative Policy Optimization. It's a reinforcement learning algorithm which works as an objective function. Is like a recipe for teaching a model to get better at generating answers by comparing its own responses and improving step by step. Now, two main keywords over here, own responses, so own, and getting better. This is primarily done with something called a reward function. Reward functions are very common in the reinforcement learning world. So in this case, we're going to be training our model with three different types of rewards: accuracy rewards, format rewards, and language consistency rewards. Based upon the scoring it gets in these three categories is how the model is going to get improved. So what's the difference between GRPO and fine-tuning? If you guys didn't know, I make a lot of videos about fine-tuning LLMs. GRPO is essentially another step or a next version of fine-tuning LLMs. So the main purpose of fine-tuning LLMs is that it adapts LLMs to specific tasks, whereas the GRPO aligns LLMs with human preferences and predictive objectives. So pretty similar, but it does have a slightly more edge. When it comes to the method, you fine-tune models with labeled dataset to modify weights, whereas it uses reinforcement learning to optimize responses. It still uses some sort of response, technically labeled data, quote unquote, but still is a bit more reinforcement learning focused. Now, there are different types of trainings. You have full fine-tuning using a LoRa and adapter-based, whereas GRPO is alternative to reinforcement learning with human feedback, which has been used for the GPT-4o and other models, and it is more stable than PPO, which is another type of reinforcement learning algorithm. Fine-tuning, however, can suffer from catastrophic forgetting, whereas GRPO preserves general knowledge better. And the use cases for fine-tuning LLMs is for specialized chatbots, domain-specific LLMs, if you want to if you want to train the model to respond in a specific way, whereas GRPO is more about aligning models to more helpful, safe, and human-like alignment. Now, let's get into the nitty-gritty on how to actually use GRPO for training our Deepseek model. This video will be broken down into 7 different sections. We're going to install our packages, download our model, prepare our dataset. We have to define some reward functions and define training arguments. We're going to train and save the model, do some inferencing, and also show you guys how to use it with VLLM, plus GGUF, and some more. So let's get into it. So the first thing that we're going to do is we're going to install Unsloth VLLM, and we're going to upgrade our pillow, and then we're going to start loading our model. Now, before we start loading our model, make sure you guys have the HF token in your environment enabled. This can be accessed through the Hugging Face settings page, and make sure you guys store that in your environment. After we do that, we are going to load the fast language model and patch fast reinforcement learning, which is going to fix or patch this fast language model for Xformers. After we've done that, we are going to load Unsloth and Torch and define these two parameters for max sequence length and lower rank 32. And then we're going to call the fast language model from pre-trained, pass in the model name. In this case, we're going to be using the Deepseek Distill Llama 3.18 billion. And then we're going to pass in max sequence length, load in 4-bit, and fast inference to true. We're just going to load the model with VLLM. And then we're going to pass in max lower rank that we defined earlier and GPU memory utilization 0.6. By the way, we are using a T4 GPU, which is a free GPU, by the way, so you don't have to pay for anything. And then we're going to define the target modules. This will essentially focus on specific modules of the LLM. So we specifically train those parameters without blasting our entire GPU. This will not only make it faster to train our model, but also make it more efficient and also save costs. It has been loaded. Let's actually prepare our dataset. So the first thing that we will do is import datasets, load datasets, and RE to be able to manipulate our strings. And then we're going to define a system prompt that we're going to use to load our dataset, and also define a chain of thought reasoning format for XML data. Now, when it comes to XML data, we are going to define an XML extraction function that's going to split it based upon the answers tag, and then extract the answers based upon these tags over here if they exist. And then after that, we are going to load our dataset. So over here, we're going to define a function called get GSM 8K questions, which is a question answering dataset. And although we're going to be taking a specific split of it, we are going to take only 100 samples. So to do that, we are going to load the dataset like so. So we load the dataset with the training split and selecting only 100 samples. Now make sure you guys take away this 100 if you guys want to train with the entire dataset or specifically with your own dataset. And then we're going to initialize this function to actually load the data. And now we finally get to define our reward function. This reward function will be used during the training procedure in order to train the model. So the first thing that we're going to do is define the correctness reward function. This essentially rewards correct answers and valid numerical outputs. We can have another one called int reward function. This also does the exact same thing. It rewards correct answers and valid numerical outputs. We can define two format-based reward functions, namely straight format reward function over here, and then soft format reward function. These essentially ensures a structured output with XML adherence. And at the end, the XML count reward function gives incremental rewards for partial formatting correctness. So after we've done that, now we get to actually define our parameters for the training. To do that, as we typically do with transformer reinforcement learning, we loaded the GRPO config and trainer, and we're going to pass in these parameters. We're going to pass in the use VLM to true. We can define a learning rate, atom beta 1 and beta 2, weight decay, warm-up ratio, scheduler type, cosine, atom optimization, logging steps, prompt length, and many more arguments. Now, these numerical arguments over here can be mixed and matched and tested with to see which one performs best for your specific data and use case. And then make sure you guys use some sort of logging tool. This can be weights and biases or many others. Over here, this reports to none and saves all the output in an output directory over here. But it is highly recommended you guys actually save it in a system. You guys can easily see which one works best for your specific use case. So now we loaded the training arguments. Now we actually get to train our model. Over here, we load the GRPO trainer, we pass in the model, the tokenizer, and the different reward functions we defined over here. Now these reward functions that I discussed earlier can be adjusted for your specific use cases, but in this case, we are using it from the Will CCB, who kindly provided these reward functions. Now, let's actually train the model. Finally trained. Now we can actually start doing inferencing. So start off with, we're going to tokenize some queries. So we're going to calculate pi, and then we're going to import VLLMs, sampling params. We're going to initialize this sampling params from VLLMs, and then we're going to get the output using our newly trained model. We're going to write output at the end just to see how the output actually looks like. It's going to take some time, so please be patient. And then of course you can save the model using LoRa. And there we go, there we have an output. Whilst the model is saving, now we can load the LoRa and test it as well. And it should return a similar output using system prompt. Now, I've shown you guys how to train the model, how to make inferences with the model using VLLM, but how do you actually save the model for VLLM inference? And to do that, I've actually provided the code on how to save with different bits over here, including LoRa. Now, I'm also going to give you guys a code for saving it for using GGUF format to be able to inference it with Llama CPP. Now, a special thanks goes to Unsloth for providing this type of code so I can show you guys how this works. Alright guys, I hope you found this video insightful. If you guys did, please feel free to subscribe. I make similar videos like these. Alright guys, I hope to see you in my next video. Have a nice day.